Hello and welcome to the Titus Timeout Podcast. I'm Jenny Abney-Civey, and today we're going to talk about sizing VAV boxes. In the previous podcast about single duct boxes, fan boxes, and dual duct boxes, I discussed their operation, but I really didn't get into how to size them. So I want to follow up on that a little bit. Let's start with the primary air inlet. Our catalog shows the airflow range for different inlet sizes. So for a 4-inch inlet, the inlet CFM is shown as 0 to 225 CFM. For a 5-inch, 0 to 350, 6-inch, 0 to 500, 7, 0 to 650, 8, 0 to 900, 9-inch, 0 to 1050, 10-inch, 0 to 1400, 12-inch, 0 to 2000, 14-inch, 0 to 3000, and 16-inch, 0 to 4000. So let's talk about the low end first. 0 is obviously a closed damper, but can you really put 1 CFM through a 10-inch inlet? Well, yeah, probably you can, but you won't be able to measure it. So manufacturers publish minimum CFMs. Something to know about the minimum CFM of a VAV box is that it's all about what the VAV box controller can measure, not what the box itself can handle. For instance, our Titus II pneumatic controller can control down to 145 CFM on an 8-inch inlet, but the Titus I only goes down to 190 CFM. And then someone else's DDC controller could even go lower than that maybe. So it's really dependent on what the controller can handle. So I know a lot of people don't use pneumatics, but I chose pneumatic controllers because we know exactly what these can control down to. Okay, so how is this determined? If you remember in the very first podcast, I talked about the flow sensor in the VAV box being connected to the controller. Let me scoot this out of the way some. It's actually connected to pressure ports on a pressure transducer in the controller. So let me draw a VAV box real quick. There's the unit casing, inlet, and then your flow sensor's in here. Okay. One side is connected to the total pressure side of the flow sensor, and the other side is connected to the static pressure side. If you recall, the difference between total pressure and static pressure is the velocity pressure. So the controller uses the velocity pressure to calculate the velocity of the air moving through the box. If you remember, this is velocity equals 4005 times the square root of the velocity pressure, and then it can use that to calculate the CFM, which is velocity times area. So a good rule of thumb is that the pressure transducer in a controller needs about 0.03 inches of pressure differential. So using 0.03 as a guideline, you can calculate for each inlet size an approximate minimum CFM. If you do that, then you'll get for a 4-inch 45 CFM, 5-inch 65, 6-inch 80, 7-inch 105, 8-inch 145, 9-inch 175, 10-inch 230, 12-inch 325, 14-inch 450, and 16-inch 580. Since this is dependent on the controller you use, you may be able to go higher or lower with your minimums depending on the manufacturer of your controller. So now let's look at the maximum number. Obviously you could force a lot more air through an 8-inch VAV box than 900 CFM, but like they say, just because you can do it doesn't mean you should. Ideally, you'll want to keep the velocity through the inlet around 2,000 or 2,200 feet per minute. So let's look at that 8-inch box again. The area of the 8-inch box is pi r squared, which is 3.14 times 4 squared divided by 144 to get into feet. That's 0.349 square feet. From there you can calculate the CFM at 2,000 feet per minute as being 0.349 times 2,000 or 698 CFM. Or at 2,200 feet per minute, which comes out to 768 CFM. And if you select your inlet size so that you're near the 2,000 feet per minute range, you'll also be able to turn your box down to about 25% airflow or 500 feet per minute and still be able to maintain proper flow control. So that explains how to size your primary air inlet. So if you're sizing a single duct box or a dual duct box, because the inlet size equals the unit size, you're pretty much done. In a fan box, the inlet size is only half the unit size. So now let's talk about how to size the fan in a fan box. I discussed this some in the podcast on fan curves. A fan curve looks like this. For a TFS casing size C with an ECM motor, the minimum fan CFM is about 380 CFM at 0.25 inches, and the max is about 1150. If you look at several size fan boxes, you'll see that there's some overlap in the fan curves. For instance, a TFS casing size D with an ECM motor has a minimum CFM about 575 CFM at 0.25 and a maximum about 1750 CFM. So how do you know which one of these two to select? So it's best to select in the top half to third of the fan curve, because as you turn down the box, the motor will become less efficient. My example is an ECM motor, so it stays pretty efficient throughout the entire operating range, but it still will become less efficient as you turn it down. So for our example, if you need 770 CFM to match the primary airflow, because this is a series fan box, you would want to select the size C TFS, because it's about halfway up in the airflow range, whereas in the D it's near the bottom of the curve. So you would select a TFS-C with an 8-inch inlet, which is what we would call a CO8. Now if you needed 700 CFM, there would actually be 3 possible unit casing sizes that would work, because the size B TFS with the ECM motor has a fan curve that has a maximum at 720 CFM at 0.25 inches. But in this case, you would be right at the top of the fan curve. Selecting here doesn't give you much leeway in case the pressures are higher than expected or your airflow requirements change. So that covers sizing VAV boxes. Don't forget to subscribe to our YouTube channel, and thanks for taking the time out with us.